All right, welcome to the Explainer. Today, we're going to pull back the curtain on a concept that's, well, it's pretty much fundamental to the entire data world: organizational data architecture. It might sound a little intimidating, but honestly, just think of it as the secret blueprint for how information flows. And hey, by the end of this, you'll know exactly how to read it.
So think about the last time you used a food delivery app. You tap order and poof, like magic, a meal appears at your door. But that magic is really just a super complex system of information flowing perfectly. So what's really going on behind that simple tap?
Well, what's happening is that you've just sent a signal into this bustling city of data. A city with roads, houses, traffic lights, the whole shebang. The plan for that city, its blueprint. That's what we call data architecture. And today, we're going to become its chief architects.
All right, Section 1, your data's hidden city. Let's start by really digging into this core idea.
So what is it, formally speaking? Data architecture is the master plan. It's that high-level blueprint that dictates how an entire organization stores its data, how that data moves from A to B, how it's governed to keep it safe and sound, and, critically, how the whole system can grow without just falling apart.
And here's how that city plan maps directly to our data world. See the houses. That's your data storage, things like databases and data lakes. The roads are the pipelines and streams that move all that data around. Your traffic lights? Well, those are your government's rules, controlling who gets to go where, and the street signs? That's your metadata, telling you what the data is and where you can find it. Make sense, right?
Okay, Section 2, the architectural blueprint. Now that we have the map, let's break down what it actually does.
You know, at the end of the day, any data architecture, no matter how ridiculously complex it seems, is really just designed to answer these four fundamental questions. Where does the data live? How does it get from one place to another? Who is actually allowed to see it? And the big one, what happens when we get way more users, way more orders, basically way more data? Does it all just break?
Theory is one thing, but let's make this real. We're going to invent a food delivery app, let's call it Hungry Now, and we're going to see how they would build their data city from the ground up to answer those four big questions.
Now look at this sentence. I know, it might look like a whole lot of jargon right now, but this is our goal. By the end of this explainer, I promise you'll not only understand what every single part of this means, but you'll be able to confidently say something just like it about your own projects. So Hungry Now uses what we call a hybrid approach. They pick the right tool for each job. For those core transactions, orders and payments, they use a structured SQL database. That's their OLTP system. For all the messy, semi-structured stuff like app clicks and driver location pings, they use a NoSQL store. They use event streaming to get those live driver updates to your phone. And all this raw data gets dumped into a data lake, which they organize into zones, from raw bronze data to clean, refined gold data. That gold data then feeds a data warehouse with these super organized star schemas to make their business dashboards run crazy fast. And how does it all get connected? Through data pipelines that run ELT jobs. We'll get to what that means in just a sec.
So, Hungry Now made some very specific choices. Let's look at the menu of options that they and you have to choose from. This is basically your toolkit as a data pro.
Here are the greatest hits, really. You've got your classic relational databases for clean, structured data like tables. NoSQL for more flexible, kind of messy data. Data lakes for just storing absolutely everything in its raw format. And data warehouses for that optimized high-speed analysis. And of course, you've got all the tools to move and process it all.
Okay, this is a crucial point. Architecture is all about trade-offs. You can't have it all. A really big one is batch versus streaming. Think of batch processing like running your dishwasher only once a day. It's super efficient, cheap, and simple, but you have to wait for it to finish. Streaming, on the other hand, is like washing each dish the second you're done with it. You get results instantly, which is awesome, but it's way more complex and expensive to run.
And here is another classic trade-off. ETL versus ELT. The only difference is when you clean and shape your data. In the old days, with ETL, you'd transform the data before it ever got to the warehouse. But now, with these incredibly powerful modern warehouses, ELT is super popular. You just load all the raw data in first, and then use the warehouse's own muscle to transform it.
It's often way more flexible and easier to scale.
So we've got the concepts, we've got the tools, but why does any of this blueprint stuff actually matter? Let's connect this right back to your daily job, the business you work for, and, for a lot of you, your endpoint assessment, or EPA.
Look, for you as an analyst, it's simple. It means you know where to find the good, reliable data. For the business, a good architecture is the foundation for everything, for growth, for security, for making smart decisions fast. And for your EPA, this is the key. Describing the architecture proves you see the big picture. It shows you understand how your one little project fits into this massive, interconnected city of data.
All right, let's get to the best part. I'm going to give you some powerful phrases you can basically just copy, paste, and adapt for your portfolio or use in your EPA to sound like an absolute pro.
This one is a total classic. It shows you understand the overall pattern, a hybrid model, and you can justify a key technical choice, using ELT, by tying it directly to a business need, which is scalability. It's just perfect.
Now, this statement is fantastic. Why? Because it demonstrates you know a specific modern pattern, that medallion architecture, the bronze, silver, gold thing we talked about. And you connect it to security. You're mentioning role-based access control, or RBAC, on your most valuable data layers. It's very impressive.
Oh, now this is a top-tier answer. You're showing you actually evaluated a trade-off, batch versus streaming, and then you made a specific, smart choice to meet a clear business requirement, a 15-minute service level agreement, or SLA. That means the business needs that data refreshed every 15 minutes, and you're explaining exactly how you made that happen.
And finally, this one just screams, I get it. It shows you understand the right tool for the right job principle. You're justifying a classic star schema because it's great for BI performance, while also justifying a totally different tool, NoSQL, for a use case where it excels, handling tons of fast-moving app data.
So, remember this. Data doesn't just float around in the cloud somewhere. It lives in a system that is carefully, thoughtfully engineered. It has a map. After today's explainer, the only question left is, how are you going to describe yours?